All right. So, God, act like you mean it. Oh, yeah, I think your glasses, are they still on the back table over there? Be nice. All right. So we did this one yesterday, so we don't need to copy that one down again. We did that one yesterday. So we're going to look at the bottom one, and we are going to be factoring it. I'm going to do our factoring by grouping. But we're just going to, so it's just the one on this page, and then we'll go on to some other things. So, there it is. First things first, we need to check for a GCF. Does this one have a GCF? No. It looks like it should, but it doesn't. So what we need to do is we need to figure out how to uncombine the like terms from the middle piece. So I'm going to use my X frame to do so. That's when we use our A times C at the top, B at the bottom. My A is 4, my C is 25. So my A times C at the top is 100. And my B is negative 20. What is a pair of numbers that's going to multiply to make 100 and add to make negative 20? Negative 10 and negative 10. So that tells me how this middle term splits apart. So what we have is our 4a squared minus 10a minus 10a plus 25. It splits that apart. It uncombines our like terms. Like I said, there's a gazillion ways to factor. I'm going to factor with the grouping. So I'm going to break these into pairs. I'm always going to take, if there's a minus sign, I always put it inside the parentheses. And then I sneak a little plus out here to remind me that I'm adding. Because plus negative 10 is the exact same thing as minus 10. And I want to keep that insert there so we make sure we remove with the correct sign. So we look at each of these pairs individually for grouping. So what is a common factor between 4a squared and minus 10a? 2 and a. And that's going to leave us with 2a minus 5. Then I'm going to do the same thing on the second pair. What is shared between minus 10a and positive 25? 5. But if there's a minus in front, we want to take out a minus 5. We don't like to start things with negatives because that's why this felt weird. So I want to take out a minus 5 as our GCF because that's going to leave us with 2a minus 5. These two pieces have to wind up exactly matching. If they do not wind up exactly matching, something went wrong. The most common thing that goes wrong is that we forgot to take out a minus sign. If they are the same thing but with the signs reversed, we forgot a minus. Because the way we write this in our factored form is these two things get pulled out as like a GCF. So we have 2a minus 5, and then we're going to put our leftover bits into 1. 2a and minus 5. So what we have here is 2a minus 5 squared. And there will be times when it makes more sense to write them out like this, and sometimes when it makes more sense to write it like this. At this point, it doesn't matter. When we're doing things, whether we're working with factoring, simplifying, we'd want it this way. If we're dealing with exponent laws, we'd want it that way. So there's times when we want it in either way. So it's good for us to know how to write it in multiple ways. If we start to recognize the patterns for our perfect squares, absolutely fine. You do not have to write out every single step. What you cannot do is go straight from here to here and not show me a dang thing. Okay? You do not have to fill in every single step like this, but give me something, because unfortunately my psychic powers have not yet developed. Crossing our fingers for that. But I need to be able to see your brain and how it's working. That's what the showing the work is. It's letting me into your head to see how it's going through. Okay? Questions on this one? Trying to see what we're doing next. Okay, because we're going to hit a couple of special patterns today. Like this one. We've got some difference of squares, which we might remember the special pattern for. We might not. I'm going to do one full out as grouping, and then we can do the special pattern, because once we see it, once we usually spot it. So even if we don't remember the special pattern for difference of squares, we can factor it exactly the way we did on the last few. 100%, I can come through here and do my x and try and figure out my pair of numbers. My a is 1. That minus 9, that's my c. So we wind up with a minus 9 at the top. And what's my b? 0. I have no b. So we need a pair of numbers that multiplies to make negative 9 and adds to make 0. Negative 3 and positive 3. Negative 3, positive 3. Again, I said I'm going to do this whole one by grouping, and then we'll talk through the special pattern shortcut if you want to. Again, since this one also has a of 1, you could use that shortcut. There's several shortcuts available on this one. I'm going to do, like I said, the whole thing. So we've got our x squared minus 3x plus 3x minus 9. Again, you do not have to write out every step I do. If I do it with grouping, I'm going to break them into pairs, like this, pulling our GCF out of each pair. What is shared between x squared and minus 3x? X. Just an x. So we have x and our leftover x minus 3. In this second pair, what is shared?
3.
A positive 3. And that's going to leave me with x minus 3. So my two green blobs match, which means we did it right. So I'm going to put my x minus 3 in front. And my leftover bits in their own. We have the x plus 3. So that's doing it full out. As like I mentioned, there were two shortcuts that we could see there. We could either do the fact that a is 1 and hop straight down to the minus 3 plus 3 from the x frame. Or we can notice our difference of squares pattern, which I'm going to write over on the right-hand side, where if I have something squared and something else squared, our factored form is going to be a plus b, a minus b. One with a plus, one with a minus, but the square root of each of the terms we start with. So we have to be really, really careful, especially on ones like the next two, that we make sure we catch the whole term as a perfect square. So with our 16x squared, this is a whole piece. It's not just 16 and x that we're going to have in our parentheses. If I wanted to write this as an a squared, the whole chunk being squared, what would go inside my parentheses? What is being squared to make 16x squared? 4x. What is being squared to make 49? 7. So again, if you don't need to write this step, you don't have to, but for some people this will make it easier to spot the pattern, especially when we start doing cubes and things in a similar vein. Okay, so our difference of squares, I usually write all my parentheses first because it makes it easier. I've got a 4x in front on each of them. I've got a 7 in the back. One gets a plus, one gets a minus. It does not have to have the plus in front. You can put the minus in front, whatever way close or both. Doesn't matter what order it's in. As long as those two pieces match, we can put them in whatever order we want. Okay, questions on that one? Let's look at the next one. Looks a little bit gross. What do we see? It's definitely a thought, but what are we supposed to do first every time we factor? Check for a greatest common factor. Does this have a GCF? 3 does fit, but is there a bigger one? 9. 225 is divisible by 9. What is 225 divided by 9? 25. Okay. So this does have a GCF of 9 that we need to pull out first. So we have 9 out in front, and then what we really have left over is 25a squared minus b squared. So just because it's a difference of squares doesn't mean we get to skip the step of checking for a GCF. It's still a part of what we got to do. So what is our factored form going to be? Can we spot it from here? What's going to go as the first piece in my factored form? 5a. The square root of this first term is 5a. How about at the back half? B. And 1 gets a plus, 1 gets a minus. Again, if you want to write it full out, you can. If you want to box each time, you can. If you want to do the X frame each time, you can. Totally fine, whatever way works for your brain. With difference of squares, I will most commonly use the pattern. It will save you lots of time. It's going to come up. Okay, what's up? You're right, I sure did put 5b. Oh, better. Totally making sure we're paying attention. Like 100%. It was a test. Yeah, no, I make those mistakes constantly. When I try and talk and write at the same time, I will mix things up. So please, please, please point it out. Okay. Questions on our difference of squares. Because the next one we're going to do is another special pattern. It is our sum and difference of cubes, where we use soap. Because we got to make sure it's clean. Soap. All right. It's another pattern. It's very similar. The formal pattern is down at the bottom on the right-hand side. It's a mess. It looks weird. But we do it very similarly to difference of squares. We just have to notice that they're perfect cubes. And the way, or what the soap is that's all about our sign. So when we say soap, it means our first sign when we come to expanding this out is going to have our same sign. So S stands for same. So if we're looking at this first one, our first sign is going to be the exact same. So x cubed plus 64, we're going to use a plus first. Our second sign will always be the opposite sign. I don't know what symbol that's meant to be. There we go. Opposite. And the AP, these go together, is always positive. So we're going to set it up the exact same way we did kind of with the perfect squares, where I put them in parentheses on their own with the exponent. So with this first one, I know this is x that's been cubed, easy peasy. Something just fell off her wall, it's okay. What is, or what has been cubed to make 64? 4.
Wait.
Just made a guess? You were right. Yeah. So 64 is 4 cubed. Those are the same thing. You could also do cube root of 64 if you want to work it that way. Totally fine. So what this means is we're going to set up the pattern down below on the right-hand side. We are going to take our first set of parentheses has our A term, so there's our X, and our B, which is 4, and it gets the same sign as our expression. So it gets a plus. Okay, that's working with this bit down here. Then our next piece is we take our A and square it, this guy here. So we're going to have X squared. And then this next sign is the opposite of what was in our sentence, or our expression. So instead of a plus, we're going to use a minus. Then I take my A times my B, so we're going to have X times 4, also known as 4X. And our last sign is always positive, and it's going to be B squared. So my 4 squared, so I already heard someone say it, that's our 16. And I'm not going to say never, but more often than not, this will not continue to be factorial. There may be a rare occasion when it can, but full transparency, I don't think we ever see one. Not that I can recall. It's incredibly rare to be factorable again.
Are you done with colors? Name
Questions on our first one of these? Questions? You're stretching. Okay. Just checking. All right. Same kind of vibe on the next one. My first on this one. Is 2 a perfect cube? No. Is 250 a perfect cube? No. Uh-oh. What do we notice, though? We've got a GCF of 2. So we can still have GCFs on these. So we've got a GCF of 2, and that's going to leave me with y cubed plus 125. Are those both perfect cubes? Actually, yes. So again, I'm going to write them like I did up there with my x cubed and my 4, just so we can see that. So I go my 2, my y cubed, plus what was cubed to make 125? 5 cubed. I'm going to fix the cube on the y real quick because that just looks weird. There we go. Okay? I write it like that because it makes it easier for me to follow the pattern when it's just ABs. You don't have to write it like that, but I feel like it makes things easier. So we've got our 2 still hanging out in front. And then we're into our individual factor here. What are we going to put as this first factor? Y plus 5. We use that same sign. The next chunk, let me erase the circles off of it so we can see it without it being like weirdly circly. What are we going to put? What's our first piece? Y squared. What's our next sign? Minus 5y plus 25, 5 squared. Okay? Once we get the hang of them, they're not too brutally awful, but they're awkward to get used to. That'll unfortunately be a phrase we use frequently. Because once we get used to them, they're not too awful. But we gotta get used to them. Oh, okay.
I just came to turn in the sign from yesterday.
Goes in the bucket. I'm teaching class right now. Okay. So this next one that we're gonna do, which I believe is very much like one on the homework. Hey, that was what I was expecting. I knew I had a yes, but come on. All right. So on homework 3, there is a problem that looks very much like this. And we look at it and we go, I get that. Okay. So what I'm going to do is we're going to do a little rearranging, because at the very least, I see an x squared and an x, and I would at the very least like them next to each other. I also see a minus 9y squared. Minus 9y squared, that feels like it's headed towards a difference of squares kind of dealio, right? So let's try taking this whole chonker and putting him at the end and seeing if that helps us do something different. So I'm just going to move it around. We're going to get our x's together and get that 9y squared to the end. So what we have is x squared plus 4x plus 4 minus 9y squared. Does that help us spot anything? Let me see.
My first thought is grouping them together and taking out, like, without when you get together, it's on different squares.
Yeah, first thought would be grouping and seeing if we could do it this way. If we do it this way, will I wind up with matching factors left over? Probably not, because you got that y squared going in there. So excellent thought, but not quite the grouping we're going to use. Yeah. So we're going to group our x's together with the 4 because we need to hopefully start noticing these patterns. This is actually a perfect square. Let's factor it and see that to confirm. So we're going to factor just these pieces I wrote in black. So we got our a times c being 4, our b being 4. So we need a pair of numbers that multiplies to make 4 and adds to make 4. 2 and 2. So we can do this. You can break it up into other chunks. Again, those match, so we're going to wind up with x plus 2 times x plus 2. And this guy's still hanging out over here. We've got our minus 9y squared. And this would be one of those times when it really helps for us to notice I can write that as a exponent. X plus 2 squared. So we're going to do x plus 2 squared minus 9y squared. Now do we see the difference of squares? It's a weird one. Like, I get it. It's super weird. That's why I wanted to do one like this. Because now I can use my difference of squares pattern on these weirdo chunks. So our first piece is this guy. The thing that's being squared first. We've got x plus 2. That's my first piece of the factor. X plus 2. X plus 2 on both. It's the chunk. So this does not change signs. What is the squared term of this? What's going to be our back factor, our back piece? 3y. 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 And it's between those two chunks where we have our sign difference. We get a plus on one and a minus on one. It's not all the signs in it. It's just the one between my two factor pieces. And I'm 100% okay with you just like writing them in this order. They do not have to be in any kind of standard form. If it helps you when you're writing this step, leave these in the parentheses until you get past everything being written in. You don't have to. I prefer it be written without the parentheses, but like is a lot. Okay. So there's one on the homework that's very, very, very similar to this. I do not remember which number, but there's one on there that you look at and you go, is this? Okay. I just had that specific note on there. So, since it's a Friday, and we have 10 minutes, and the other class is actually taking their quiz today, I think. So, they're probably not going to get ahead of us. Let's take the last 12 minutes. If you want to work on the homework, ask questions, work together, whatever you need to do. Because this factoring is going to be important because when we come back on Monday, we're going to be looking at these kind of guys. You've done these before. You've done these before because we did them in Algebra 2. Factor and simplify. You've done it. Okay. So homework 1-3 is due on Monday. You do not need to start homework 1-4. We'll talk about that Monday. It will still also be due Wednesday probably. So I put this up here, but 1-3 is due Monday. Use this time. Work on it. Ask questions if you got them. Work together. I don't care. Do what we need to do. Okay?